Okay, for these, this really goes with what we did a couple days ago. We're going to check to see if we have right triangles using the Pythagorean Theorem Converse. And then we're also going to deal with special right triangles. And you will most likely need a calculator for these. So let's see what's up. Now, for this sheet, it's 10 points. Either do the evens or the odds. We're going to do the odds as a reference. This is important. If a squared and b squared is bigger than c squared, then all the angles are less than 90 degrees. If a squared and b squared is equal to c squared, we have a right triangle. And if a squared and b squared is less than c squared, we have an angle in that triangle that's going to be greater than 90, which makes it an obtuse triangle. So we're going to do the odds on this first section. So we got 5 squared and 6 squared, 25 and 36 is going to give us 61. So we have 61 versus 49 for the 7 squared. In this case, a squared and b squared is greater than c squared. That's going to cause this triangle to be an acute triangle. Let's look at number 3. We've got 2 and 2.1 squared with 2.7. 2.7 squared is 7.29. And 2 squared is 4. 2.1 squared is 4.41. So we get 8.41 when we add those together. And 8.41 is greater than 7.29. So we have an a squared plus b squared is greater than c squared. That's also going to be an acute triangle. Let's look at number 5. We've got 2 squared plus root 3 squared. Now root 3 squared is going to be root 9, which gives us a 3. And 2 squared is 4. And 4 plus 3 gives us a 7. And 5 squared is going to give us a 25. So we got 7 versus 25. 7 is less than 25. A squared and b squared is less than c squared. That's going to cause this to be an obtuse triangle. Let's look at number 7. 6, 8, 10. 6 squared is 36. 8 squared is 64. That gives us 100. And 10 squared is 100. This gives us an equals, and that goes with a right triangle. Looking at number 9, we have 9 squared and 40 squared. 9 squared is 81. 40 squared is 1600. This gives us 1681. And 41 squared is also 1681. Oops, 81. So we have another equals. That gives us a right triangle. Okay, let's look at number 10. Find the missing lengths. These all appear to be special triangles. Maybe this one down here is not. So let's see what we got. So we have a 45, 90 triangle. Remember the ratios of side lengths in a 45, 45, 90. We have 1 radical 2. And then for the 30, 60, 90s, where this is the 30, we have 1 radical 3, 2. So we're going to use these. So if 10 is one of the legs, the other leg is going to be 10, and the hypotenuse is going to be 10 times the square root of 2. I meant to just do the odds. Okay, so we'll do the odd over here. Here we have another 45, 45, 90 triangle. If one of the legs is root 2, x also has to be root 2 because it's the other leg. And then root 2 times root 2 is going to be root 4. The hypotenuse is going to be the square root of 4, which is 2. Let's look at number 13. Here we have a 30, 60, 90. This has a basic 1, root 3, 2 set of side lengths. So 20 times 2 is going to be x. That's going to be 40. And 20 times radical 3 is going to be y. So we get 20 root 3. So get number 15. We have a square with a diagonal here. This is x, this is x, this is 8. So this is basically a 45, 45, 90 triangle. Let me switch colors. And x times the square root of 2 came out to be 8, so we need to divide the square root of 2 out of 8 and get simplest radical form by rationalizing the denominator. And we end up with 8 square root of 2 over square root of 4, which is 2, and that simplifies to 4 square root of 2. So x is going to be 4 square root of 2, and this other x is going to be 4 square root of 2. And when we do that times radical 2, we get 4 times 2, which gives us the 8 for the hypotenuse. Let's look at number 17. In 17, this is a 2 opposite the 30. So in this triangle here, we have a 1, radical 3, 2 thing going on. If this is a 2, double the 2 makes z of 4. And square root of 3 times 2 makes y 2 square root of 3. So this is a 2 now. Now here we have another 30, 60, 90 triangle. Now this 2 side is actually the medium sized side in this 30, 60, 90, which means x times square root of 3 came out to be 2. So to see what x is, I need to divide square root of 3 out of 2. And we need to rationalize the denominator. We get 2 root 3 over 3. And that is going to be our x. 2 root 3 over 3. Now double the x, or double the short side, is going to be our hypotenuse. So 2 times 2 root 3 over 3 is going to be 4 root 3 over 3. And we have those done. Let's look at number 19. Find the perimeter of a square with a diagonal of length 12. So here's the diagram that goes with it. The diagonal is 12. It's a square, which means that we have this isosceles right triangle made by the diagonal. Heck. So that means that the side, our x, times root 2 came out to be 12. So we need to take 12 and divide root 2 back out of it to see what our original x was. We have to rationalize the denominator. We get 12 root 2 over 2, which simplifies to 6 root 2. So x is 6 root 2. And we could check it out. If you do 6 root 2 times root 2, you get 6 times root 4, which is 6 times 2, which does give us the 12, so we can check it out. Okay, I'll look at these others in case you decide to do the evens. Equilateral triangle, side 16, find the length of an altitude. So here's, let's do a diagram that goes with that. So here we have equilateral triangle, 16, find the length of an altitude. In a equilateral triangle, the altitude bisects the base. So we've got an 8 with a 16 for the hypotenuse, and they want us to find the length of the altitude here. This gives us a 30, 60, 90 triangle. This is the 30. This is the 60. So 8 is the short side. Double the 8 is the hypotenuse. 8 root 3 is going to be the length of the altitude. Here we have one that has an altitude of 5 root 3. Find the perimeter. If the altitude is 5 root 3, that was root 3 times the short side, which makes that a 5. Because of the bisection of the altitude, that makes this a 5. This is a 10. It's equilateral. That means all these side lengths are 10. And we could check it. 5 times root 3 gives that. 5 times 2 does give us the 10. This has a perimeter of 30.